All right, we're going to go over the Unit 3 and 4 cumulative review. So it's going to cover the normal model and all of our bivariate data. So here we have a couple of things. One of the skills to learn here was to be able to read the computer printout and be able to understand various things about the residual plot. Okay, so our first question, so this was the fuel consumption in the railroad cars. Is a linear model appropriate, and how do you know? Well, we need to look at the residual plot. If there is a pattern, how do you know if data is linear or not? Well, you need to look at the residual plot. If a pattern is what you see, then you must say, yikes, the data's not a line, no line. Okay, so looking at this, we've got lots of good just random scatter. So no pattern. So a linear model is appropriate fit. No pattern in the residual plot. That's what you had to say to support that statement. State the LSRL. Okay, it's just kind of like you know where these things are or you don't know where these things are. Here is the slope right here. This variable is the x variable, if you didn't know that. And then here is the y-intercept. So you've got this 2 point, and I rounded 15 times. So predicted fuel consumption, don't forget that, equals 2.15 times the number of railroad cars plus 10.68. Now, what percent of variation in the fuel consumption, that's the y, can be explained by the linear relationship between x and y? Well, the idea here is you're supposed to hear that topic or that definition, the percent of variation that is found in the y. It can be explained by the changes in the x, or it can be explained by the model itself, which is the linear relationship between x and y. So this problem was just asking for you to identify the coefficient of determination, which is r squared. So you just came up here and you found r squared, if I can move on up there, and r squared is here, not r squared adjusted. So 0.967 or 96.7%. All right, next we were wanting to use the residual plot on the previous page, okay, to determine the consumption at 27 and a half railroad cars. Well, I was thinking, how can you have 27 and a half railroad cars? Well, that's the railroad car plus the caboose, which is a little smaller. So I guess it counts as a half. So that's telling me X is your 27.5. You're going to compute the actual fuel consumption. I can figure out predicted by using the prediction equation. So I put that in there and I get the predicted amount of fuel consumption. And then they tell me, do they tell me that the residual is 6? Oh, no, they don't tell me the residual is 6. Here's something important. You had to come right here and see this is what was predicted. So this is the residual to what actually happened. So what actually happened was 6 above what was predicted to happen for 27 and a half railroad cars. And that's how you would also interpret that residual. The residual of 6 says that the actual fuel consumption was 6 above what it was predicted, the fuel consumption that was predicted to happen for the railroad cars, 27 and a half railroad cars. Okay, so then that takes us to plugging in the information, residual equals y minus predicted y, and that's how you get your stuff there. 5 is the same. Okay, so 5 is the identical. You had to do not for 47 railroad cars, so watch out there. It was for 47 and a half because 47 plus the caboose. And so you just had the x, you plugged the x in to the prediction equation to get the predicted fuel consumption. So I can see over here that the predicted fuel consumption was 112 point whatever. And then what actually occurred was this much below, how much was it? 3 below the amount of fuel consumption that was predicted for 47 and a half railroad cars. Okay, so there is, once you put that all in there, see that residual was -3, and there you go. So um, I'm surprised that I didn't ask for the interpretation of that residual, okay? But make sure you do know how to interpret that residual and get a full interpretation. Here we go. What's the average amount that the actual Y, which is the actual fuel consumption, varies from the predicted Y? The average amount that the actual Y varies from the predicted Y is just asking you, that is the definition for the standard deviation of the residuals. So you had to know that that's right there on the formula or on the computer printout. So that was 4.361 units per mile. Fuels, Y. It was the whatever the Y units are, fuel consumption. Fuel consumption. Okay. Would it be reasonable for us to predict all the way out at 65 railroad cars? And that answer, what they're getting at with something like that is, look, our data goes through 50. So predicting out here at 65, who knows? This thing may level out. And so predicting out at 65 is not going to be a very good prediction. So no, that's called extrapolation. Okay, predicting out there is not going to be good. The correlation coefficient measures the strength of linearity between quantitative. Keep that in mind. Make sure you note that that's not categorical. All right, so here they wanted to know, does the model overestimate or underestimate what actually happened? Okay, so a couple things you had to do and know to get this problem. You had to be able to use this printout to get the equation, the prediction equation. Okay, so that's this. All right, and so then they said the total length, which is the x variable, is 59. So that meant that I took that 59 and I plugged that into the prediction equation to get the predicted tail length. We were predicting the tail length. So that's the predicted y. So I just go, okay, the residual is the actual y minus predicted y. So the residual is 1.32. So that means the actual is above the predicted. So the predicted is below what actually happened. So the predicted is underestimating what actually happened at 59 total length, 59 centimeters total length. All right, so here's some interesting things on this one. Here we were first asked to draw that least squares regression line. So make it pretty much so it's going through the data as best you can. And then it said, oh, what if you have a 67-inch tall father and a 61-inch tall woman? That's this right here. So that's that point. And the question is, estimate your residual, which yours may be a little different than mine, but mine was around -2. Kind of just depends on exactly where you got your line. Next question is asking us, okay, well now actually compute what that would actually be, okay, through the using the LSRL. So it had given us the LSRL. It gave us this, okay? So we just took that X, plugged it in, and got the predicted Y, and then we could do the actual Y minus the predicted Y. So that was -2.709. So I was a little off. And so it said how does your residual compare? Mine was a little smaller. All right, what if 8471 was added to the set? So let's take a look at that. That's this one right here. 8471 is that point right there. So the interesting thing is that I don't really think that I would necessarily classify this as an outlier. I know it's going to ask me that. Now, it has high leverage because it's far out in the x direction. But look, its residuals are really not that much different than a lot of these other residuals. Look, that one's even a higher residual. See? So these residuals are not too far off from the residual that 8471 is. So because of that, I don't really necessarily think this point is an outlier, nor is it going to be very influential, maybe slightly, but not, I don't think, really an important amount of influence to change what is going on. So that's what I said here. I would say the point has high leverage. It's far out in the X direction. It may be slightly influential, but not really. It's very going to be very little, if any. Would you consider this point an outlier? No, because it has about the same type of residuals as other values. Okay. How do you expect the slope to change? It's probably not going to be much change at all. It says, now I need to think, which direction is it going? It says when that is added to the data. So if anything, this might teeny tiny pull this down a little, but I just don't really think it's going to do much. If anything, it might flatten out the line a teeny bit, but it's really going to pretty much stay about the same. How do you expect the correlation to change? Well, since this is a little farther out and maybe, a little has a little larger, one of the larger of the residuals, maybe that point will make, let's see, adding it will make the correlation a teeny bit slightly less, but not a ton. Just like how the slope doesn't change that much. Okay, next. Describe the relationship. There is a strong, there is a weak, positive or negative, linear. So based on this, I think it's a fairly strong. Plus, look, my R was 0.86. So I computed that by square rooting that R squared, keeping in mind the positive slope. And then what happened up here? What's the residual? So I guess I brought the equation. So this equation is what the computer printout on the previous page said. So I went ahead and brought that on over. So what is the residual for a customer that is fourth in line and takes 11 minutes to check out? So that's the X and the Y. Okay. Catch, you remember how we got to pay attention to the context and the units. This problem was about seconds to check out, and 11 minutes is 660 seconds. So you got to keep that in mind, always keeping the context in mind. So I did what was predicted to happen by plugging the X into the prediction equation. So predicted 770.55 seconds, but what actually happened was 660. So that's a residual of negative 110. Maybe if you wanted to go back to minutes, about negative 1.85 minutes. I just divided by 60. So interpret that residual. That's not a song. Almost makes me wonder, should I make a song about that? But this is, so with the residual that, we can say that the actual was this much below what it was predicted to be at that particular X value. So in general, that's what you're saying. How the actual was this much different from the prediction for that X value. Okay. The actual time to check out is 1.885 or shorter than below the length of time it was predicted to check out for that X value of 4. Interpret the standard deviation of the slope. If we sample many times, I'd expect the slope you find of the relation between number of customers in line and the time to check out to vary about 35.06 seconds per customer because it's Y per X. Slope of the relation to vary about that many. Look at there. I think I can fix that units better because it's Y per X. So it's going to be seconds per customer. Okay. All right. On average. So if we sampled many times, I'd expect that slope to vary between the number of customers and the time it takes to check out to vary about 35.06 seconds per customer on average. Okay, I'm going to go and fix that. Here we go using the data above, which is more unusual. So we've got 600 on the verbal. What's more unusual, 600 on verbal or 650 on math? So we ended up using this data here, the mean and standard deviation for that English reading writing one, and then the math one. So the student scored better on the math portion because relative to the rest of the country because this is more standard deviations above the mean, because ultimately that says you're in a higher percentile if you are more standard deviations above the mean. 1.04 compared to 0.66. All right. Use the summary total. What percentile? Percentile is area below. Is a student who scored 1350. So that's my X value. So remember mean, standard deviation X, get a Z score. Don't forget to write Z equals. That Z score 1.39. Now compute the area below. Norm CDF is that area below. So that student who scored 1350 was in the 91st percentile. All right, which is interesting here. Now I said calculate your own. So I don't know what you chose. I did some research. I found some really interesting things because I took this test way back in like 1991. I graduated from high school in 92. So I learned that in 95, they did a big recentering of the average, and it actually made the average about 90 to 120 points higher. So that made me feel better because then whenever I had this verbal, I actually found that it was fairly close to, I mean, it was a little above the average, okay? But it doesn't seem so bad because back then the averages were much lower. Anyway, I was in the 73rd percentile for my verbal, 99th percentile for my math. So here we go. Next, this one, okay. So we had the 75th. So this one is an interesting problem. I gave it to you. You have a mean missing and the standard deviation missing. Two things missing, but I give you two pieces of information. So let's look at this. Here we go. All right. We've got this. We've been told that the 75th percentile, okay, so that I use that information for over here on this side. The 75th percentile, so that means the z-score is inverse norm of 0.75 is 0.67, and that goes with an x value of 24, okay? Then the next sentence, the 25th percentile, which is your Q1, goes, so that z-score is inverse norm of 0.25 or negative 0.67, goes with an ACT score of 16. So look at my picture here. This is saying that from 16 to 24, you are going this many standard deviations wide, from negative 0.67 up to positive 0.67. Well, negative 0.67 up to positive 0.67 is a spread of 1.34 standard deviations wide. So this means 1.34, this is 1.34 standard deviations wide is the same distance as 8 points on the ACT. So because of that, I can find then, solve for, I just divide by 1.34 on both sides, 8 divided by 1.34, and that's how I get a standard deviation of 5.97. So once I get that, so I kind of did, I don't know what method you would call that one. There's different things you could do, but once I've gotten that standard deviation, then I'm going to go substitute it back into one of these locations. Pick one. I usually pick this one because it's got the positive z-score. Okay, so I had that. So now I have this z-score, the x minus the mean, and now I have that standard deviation to go along with that. And so then I do the algebra to solve. And that's how I get the mean of 20 points. It came out to be like 20.001 or something along those lines. Okay. Now, next, in case you didn't get number 17 or number 20, I went ahead and gave you some information. The 21 2019 ACT had a mean, and I looked all these numbers up, had a mean of 20.8 and a standard deviation of 5.8. What ACT score does a student have to score to rank no lower than the 8% in the nation? So I actually put that wording in there on purpose because I wanted you to think no lower than 8% of the nation. That means the top is the 8%, not the bottom percent. So it's inverse norm of 0.92 or the right 0.08. Then you get that z-score, and then you set it up with that x minus the mean over standard deviation, and you solve. So you need to get, so let's think about this. This actually was some wrong answers on the last test. So let's take a look at it. If you got a 29 on your ACT, then you are about right here. You are below this line right here. You are not, if you get a 29 on your ACT, you are not in the top 8%. You had to score 30 or higher to be in that top 8%. You have got to pay attention to which side of the fence, and don't just think, oh, I'm going to round to 29. No, because what that is saying is you are below the fence. And to be in the top 8%, you have to be above that fence. So context, pay attention to context. All right, number 22. So this was an interesting problem. Here we had, what I did was I kind of did something like one of the AP problems we went over with when it was asking about short rectangle people and tall rectangle people and their arm span and their height. I was thinking, okay, well, let me just put in here what it would be like if the male rated the same as the female. So if they rated the same as the female, then they would be dots right there on any couple that was all on that line rated the husband and the wife rated the same. Well, that didn't happen. Most everybody was down here. Down here says that these Y values were less than the X values. And if the Y values were less than the X values, then the husbands tended to rate the quality of living higher than the wives. Okay, I did actually go through all these other ones to verify, and I've got some notes here why those other ones are not true, but I'll just leave that right there. That was the key to understand really what was going on here in the relationship. All right, having a negative correlation. As the x's get larger, the y's are getting smaller. So as one variable gets bigger, the other gets smaller, or vice versa. I mean, we could go the opposite direction with that. If the x's are getting smaller, the y's are getting bigger. All right, hence answer B. Number 24. Oh, this was a good problem. This was from an actual AP multiple choice question. So here we go. The sum of the residuals is always 0. Now you need to notice that this is not a residual plot, okay? So what I did was I put the line of best fit in there so that I could kind of see what I could kind of guesstimate what this residual plot would look like. So if that line went in there, then here is that line that's corresponding with that. So then you can see these points, kind of getting more varied as you have higher doses of medicine. Hence, D is the answer. The variation in the hours of pain relief is not the same. You're much more varied in pain relief on the higher doses. Okay, so interesting. All right, and then this last one, I put in that line of best fits, and I think the best answer of all of these is that it may be close to 1, even though the relationship is not linear, because the data is fairly close to that line. It's pretty closely clustered, but I can tell that if I did a residual plot and it really accentuated those distances, it would look something about like that. All right, I think that's the end of your review. So, just make sure, in addition to this, that you know the all of the sayings. So you need to go back through your packet or go to that linear model playlist and go through all of those things. I also think on this, I didn't ask you to like create the equation of the line from summary statistics again. So even though this is your review, please do not negate the assignment that you had right before this, before your last quiz. That would be a good one to look at also. So I would study this assignment 7 and that review and make sure that you are good to go on both of those. Okay, good luck to you on your test.